classroom. Today we're going to be talking about how to make a topographic profile. Now before we get started, you're going to need a few things to prepare yourself. The first thing is this handout, which you can find linked in the description of this video. The other two things you're going to need is some type of measuring device. I have a simple ruler here, as well as a blank sheet of paper, preferably an 8.5 by 11 or the same size as your handout. And we'll go through what they're going to be used for. Now, of course, what do I mean by a topographic profile? Well, if this image up here that you're looking at, what we need to think about is this is looking down on the object, very much how the camera is looking down here on my table as I make this video. And our goal is we want to be able to take this 2D image and we're going to turn it face up so that we can see what a cross section of this area might look like. And now we want to choose a specific location. So I want to look from A to B. So if I cut this line AB and cut the ground right down through it, and I shifted it up and looked at the side, we want to know what would it look like. Now in order to do that, we're going to transpose this information down here. Now what we need to do first though is utilize the contour lines available. So we can see the contour lines here. We have a contour interval of 100 feet. And this is where this handy dandy paper is going to come into play. So if I take your paper and you're going to lay it down along our A to B line, because that's the line we're concerned about, because we're going to cut the land right along that line. Now I'm going to use different colors here for this illustration, but you can use symbols or whichever you prefer. So what I need to do is I need to mark anytime a contour line is coming into contact with my A to B line. So first we're going to start with this outermost circle here. Now if I wanted to know what size, well I can see 300, 400, so this must be 500. So let's mark every time 500 crosses the AB line. So that would be there, right here. Let's see, now 400, 500, so that would also be right here. And that I think is it. Then I would go ahead and do the 600 line, which would be my next line in. And I can see it crosses here. Not there, that's 700, 600, and 600. Now we want to be as accurate as possible because it's going to definitely change what our image looks like. And our last one here, we're going to mark this 7. Whoops. See, now there's a key error that can happen. Make sure that you keep your paper flush with both sides, meaning here of the paper, so then it's right in line. You could, of course, do this with a straight edge, but it's not... It can be a little more challenging, but whichever method you choose is up to you. And then what we're going to do is we're going to shift this information down to the chart below. So all I'm going to do is drag it down here. And you can see that the chart down here also has measurements. On the left-hand side, we can see that this is 800 feet. Well, I didn't have any contour lines that crossed mine at 800 feet. So I'm going to go ahead and scroll down a little bit further. I'm going to scoot this up so you can see to 700. Now it might come out of line, so I'm going to make it flush again. Perfect. 700. So I need to mark here where all my 700 lines are. And now you can see why I chose different colors. It's just to help illustrate the lines. Now see, I just picked up blue, but that's not the right one. I want the purple one, or lavender. I see that lavender happens right here, and it happens right here. That's the only time 700 crosses my A to B line. And I'm going to do the same thing for 600. So let's scroll down a little bit further to the 600 line. That doesn't look too bad. It's flush on both sides again. And we're going to mark the 600. So mark, mark, mark. Great. And our last one, we need to mark 500. So we're going to have to scoot this down a little more because there are no more contour lines crossing the A to B line. Now, of course, there's a 400 and a 300 on the plot, but not around crossing the line that we're interested in. So I'm going to go ahead and mark that. Now I'm going to take this sheet away. I don't need it right now. Now, hopefully you can see those darks or those marks. I'll color them in here just a little bit so that you can see them a little bit clearer. Here, 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 and the purple ones are right there. Now our goal is we need to connect these dots, but we also need to keep in mind that we're paying attention to the elevation. So we never reached 400, right? So my line doesn't start right here at 400, it needs to start ahead of it. And I'm going to go up, connect my dots. And when I get here, well, I can see on the A to B line, right, that this elevation is going to be higher. It's going to go up and go down. I don't know how much it's going to increase. I don't know how close it is to 800. That's fine. I'm just going to do an arbitrary hump here. But I just know that it doesn't go to 800 and that it's higher than 700. So some arbitrary hump. Connect my dots. Same thing, I have another arbitrary-ish valley-ish area here where I have a dip in elevation where it's not all the way to 400, but some little dip here. That might have been a little steep. And then I need to drag my line again here. Once again, it doesn't reach 700 on the end, so it's just going to kind of tail off here. Not going all the way up to 700. Perfect. And that's what I would get as my topographic profile. And that would be it. So this is what it would look like from a side view along the A to B line. Now the other piece of information we need to know is that if we look at this image and then we look at this image, we can see that the elevation is only going from 500 to 700. However, this makes it look like I'm climbing Mount Everest. And that's not the case. So I need to be sure that I am honest about what this represents. And in order to do that, we calculate something called the vertical exaggeration. Vertical exaggeration. I'm going to abbreviate. That just means how much has this been exaggerated from the original. And in order to do that, that's where that ruler comes in that I told you to grab. What you need to do is measure the actual scale for the first photo. So if I measure the first photo, I can see roughly that it's close to 2.5 centimeters. Now, of course, you probably can't see that as clearly on the camera. That's okay. Take my word for it. It's roughly 2.5 centimeters is 100 feet here. The question I need to ask then is, well, how many feet is 2.5 centimeters down here? Now, in order to do that, I need to measure this side. So if I go over here and measure, well, look at that. 2.5 is almost exactly 400. So that means 400 feet down here is 2.5 centimeters, right? No. Common mistake. It's not 400 feet because it doesn't start at 0. This starts at 200 and goes to 400. So that means 2.5 centimeters is actually only 200 feet. So make sure to catch and pay attention to where your charts are starting at. So 200 feet here is 1,000 feet here. So in order to find the vertical exaggeration, I take the first scale, 1,000, divided by the second one, 200, which would then be 5 times. Which means that this image here is vertically exaggerated 5 times. Perfect. So great work, Velociraptors. We've covered how to create a topographic profile. Again, a topographic profile is what would it look like from a side view from A to B. We've already created that topographic view down here, and that's that profile. We calculated the vertical exaggeration, which is the scale of the first photo divided by the scale of that second photo. So that was 1,000 feet over 200 feet, which means that it's 5 times exaggerated. So great work. Look forward to the next video on creating the geologic profile, and thanks for tuning in.